So now that we know about prime and composite numbers, we can talk about the prime factorization of a composite number. So any composite number can be expressed as products of two or more whole numbers greater than 1. Each expression is called a factorization, and a factorization containing only prime numbers is called a prime factorization. The fundamental theorem of arithmetic tells us that any composite number can be written as a product of primes in exactly one unique way, up to the order of the prime factors. Okay, so if I want to find the prime factorization, I'm going to try factoring the number as a product of two smaller natural numbers. If those numbers are prime, I'm done. If those numbers, either one of those numbers is not prime, I need to factor that into a smaller product of natural numbers. And we're just going to continue until all the factors are prime. So you've probably seen this before. So I'm going to find the prime factorization of 84. This is called a prime factorization tree. So I can write 84 as 4 times 21. I recognize that 4 divides 84 since 4 divides 84. So 4 times 21. 4 and 21, neither one of those is prime, so I can factor each of those again. 4 factors as 2 times 2, and 21 factors as 3 times 7. Those numbers are in red because they are prime numbers, so I can't break those numbers down anymore. So to find the prime factorization, I'm going to look at these numbers in red, and I'm going to multiply. So the prime factorization for 84 is going to be 2 squared, because I have 2 2's, times 3 times 7. What about 495? Well, this ends in a 5, so I know that 5 must divide 495, and when I did that division, I got 99. 5 was already prime, so I'm going to stop at the 5, and I'm going to deal with the 99. 99 is 11 times 9. 11 is prime. 9 is not prime, so I can factor that down further. 9 is 3 times 3. And now I've ended with some primes, and so I'm going to look at all my prime numbers, and that's going to give me my prime factorization. It's nice to put them in increasing order, so I'm going to have 3 squared times 5 times 11 here. Okay. Here are 2 prime factorization trees for 260. Both of them are correct. So you might see it a little bit differently than someone else. So this first student noticed that 10 divided 260, so they wrote it as 26 times 10. This other student used 5 first, so they did 5 times 52. Both of these are the same. You end up with 2 squared times 5 times 13 in both cases, right? Here, I've got my 5 here, my 2 squared, and my 13. All right, I'm going to let you try this. Find the prime factorization of 504 using a factor tree. And I'm going to show you another way of finding the prime factorization. So here, we're going to write our division kind of moving downward. And we're going to start by dividing by the smallest prime that divides our number. So I'm looking at the number 260, and the smallest prime is 2, and 2 does divide 260. So I'm going to do that division. 260 divided by 2 is 130. That's what's happening here in step A. And now I'm going to just repeat. So 130 is divisible by 2, so I'm going to do that division. I get 65. And now 65 is not divisible by 2, so I'm going to move on to the next smallest prime, which is 3. 3 does not divide 65 either. So I'm going to move to the next smallest prime, which is 5. 5 does divide 65, so I'm going to do that division. I'm left with 13. 13 is prime itself. It's divisible by 13. And so I end with a 1. So if I want to find the prime factorization, it's going to be the product of these primes that I used in my division problems. Okay, so 260 can be written as 2 squared times 5 times 13.